Okay, so we're going to look at some examples of using some of the tricks of the trade in order to help us solve limits when we get an indeterminate form. So let's say that we have the limit here as x is approaching -3. In our numerator, we have x squared minus 9. And then in our denominator, we have x squared plus x minus 6. Okay, so first thing again, when we're doing limits is always try direct substitution. So we're going to plug in where the limit is going, in this case, -3, and for x, wherever we see an x. And so when we plug in that value for x, we're no longer going to write that limit. We're not going to bring it down anymore. So I'm going to go in here, wherever I see an x, I'm going to put a parentheses, and then I'll come back and rewrite it with a -3 inside. So I see an x squared, so parentheses squared, then minus 9. In the denominator, I see an x squared, so parentheses squared, plus I see another x, so parentheses minus 6. Go and replace or put in -3 inside your parentheses. Use order of operations to simplify. So we have -3 quantity squared, which is +9, then minus 9 in the numerator. All over again, we have -3 quantity squared, so that's +9, plus a negative, so that's -3 minus 6. And so looking at this, 9 minus 9 is 0, all over 9 minus 3 is 6, 6 minus 6 is 0. So this is the indeterminate form. And we want to go back and we want to manipulate this so that we don't get that form anymore. This doesn't tell us anything about the limit. So a lot of times on an exam, students will go get this form and they'll say, well, the limit doesn't exist, and that we don't know that. You haven't shown that. So now try factoring if possible. I noticed that the numerator is factorable. I see a difference of squares. So when I'm going through to factor, first thing I look at is how many terms. And in this case, x squared minus 9 is 2 terms. So 2 terms clues me into, I'm looking, do I have a difference of squares? Is there something I can square to get that first term? And then minus, is there something I can square to get that second term? Which it is. So recall, just really fast. If you have a difference of squares, so in the form maybe a squared minus b squared, this can be factored as a minus b, a plus b. Doesn't matter the order. I mean, you could have written this as a plus b, a minus b. Okay, so what do we square to get x squared, which is just x? What can I square to get 9, which is 3? So I have x minus 3 and then x plus 3. All over. So looking at the denominator and trying to factor this, I notice I have 3 terms. So if it's 3 terms, that's where you always first look to see if there's anything you can pull out of all of the terms. In either of these cases, we couldn't. But when there's 3 terms, let's see if it's quadratic. It is. I see if my coefficient, the number in front of my x squared, is 1. It is. That makes it the easier case. So we're looking for 2 numbers that multiply to give us -6 and would add to give us this middle term 1. So I kind of break it down like this. If I'm looking at it, what am I multiplying, my x, and what am I adding to try to get? So the 2 numbers that multiply to give me -6 and add to give me 1. Well, multiplying, getting a negative, one has to be positive, one has to be negative. And the bigger, I have a positive when I sum, so the bigger number is going to be positive. 3 times 2 is 6. 3 times -2 equals -6, and 3 plus -2, or 3 minus 2, equals 1. So they both check, and those are my 2 numbers. And so we're going to go in there and factor. And this will be x plus the one number, x plus the other number. So in our case, x plus 3, x plus -2, or x minus 2. Okay, so hopefully at this point you notice that there's two factors that are the same in the numerator or denominator. And we do have two factors that are the same, x plus 3 and x plus 3. So we can simplify because now this is strictly multiplication in between those factors. So let's rewrite our limit and bring down the simplified form. So we have the limit as x is approaching -3 of our numerator is left with just x minus 3, and our denominator we're left with x minus 2. So again, we're going to go back in and we're going to try that direct substitution. So wherever we see an x, we're going to replace it with a -3. We're plugging in that value, so we're going to drop the limit. We're not bringing it down anymore. So x minus, we have parentheses, -3, parentheses, -2. Plugging in -3 wherever you saw that parentheses, and then simplify. So -3 minus 3, adding two negatives, add them together, and the result's negative. So we get -6. And -3 minus 2, both negative, add them together, they're both negative. So this is -5. And we get back 6/5. Okay, so the limit as x approaches -3, and this quotient was 6/5. See how my math lab wants it? You're always gonna, if you have a fraction, you're always gonna reduce it. But this is reduced. 6 and 5 don't have any common factors. But if they say write it as a mixed number, well, 5 goes into 6 one time with a remainder of 1. So this would be 1 1/5. We could write this as a decimal. 5 divides into 6. Well, it goes in once. Add a decimal and a 0, bring down our 0. 5 goes into 10 twice. So we could express this also as 1.2.